Good morning. This morning I'm really super excited to announce that Spark 3.0 is out. That was that's a big milestone for the Spark community. Just ahead of Spark Summit next week. It has a lot of new features, including some optimization for GPU and support for GPU for machine learning and many more. That's kind of one of the one I kind of like. I will cover a lot more of that in the future sessions of DataFriday, so no worries about that. And so far, everything in Spark in Action works with 3.0, and if not, as we go further, I will post that in the addendum and the errata of the book. Don't worry. You can buy Spark in Action, as it supports specifically Spark 3. Yeah. Okay. Another great thing is I got my diploma for 2019 for being an IBM champion. That's 2020, sorry, and that's has been signed by my friend Arvind Krishna, who is now the CEO of IBM. So that's really very touching and moving. Thank you, Arvind, and thank you everybody at IBM for this wonderful program. So let's talk data, right? It's Friday, it's Data Friday, so we've got to talk data. Today I'd like to do something a little bit different than we used to be doing. I'm going to tackle a more complex use case. I actually took off from my normal day at work, so I got a little bit more time to dig into something a little bit more complex. Let me share a few things with you. Let's look at that. Okay, you probably have seen that, or you probably have seen something similar. This is the dashboard that the Johns Hopkins University is showing about COVID-19 worldwide, where they track the cases from the different from the different places, and this, as much as it's saddening and frightening, it's they are the figure of authority for that. Okay, so you see the cases in the US, Brazil, and as I record this thing, for those not seeing it live, we are, well, you see the date, it's Juneteenth actually today, and as you can see, it's really not going great. Okay, but if you want to analyze data, as you know, it's really interesting to be able to look at data in its history, and not specifically on a single day like now. So I looked for where, because there's not a link like download the files there. So I looked and found out that Johns Hopkins has a department that is the Department of Computer Science Engineering, is actually having a GitHub. Here you see the Wheating School of Engineering. They have a GitHub and they have some activities, and you see when it started, where they put the COVID-19 cases. Okay, so if you go there, you click, of course, I put the URL in the comments, and you will see the different data. And what they did pretty well is they also documented the data sources, where it's coming from. It's scientific, it's done seriously. And if we look at the different data sets, and you look at the reports, you see the reports as CSV files. Okay, and what do we all know about CSV files is that they are really easy to ingest with Apache Spark. Okay, I probably did a video on it. I don't know, maybe first video. I've wrote a lot of articles, and it's so easy that everybody is actually writing hundreds of articles on how to ingest CSV files. But where it's pretty smart is that it's actually in GitHub, so they can make some specific updates if they need to on when there's errors, and that's it. Okay, so this is the data, and what we're going to do today is ingest this data into Spark. Okay, so then you're going to ask me, or you can probably already thinking about, how are we going to do that? Okay, so let me have a sip of tea and we'll jump right in. Okay, so let me draw what we're going to do. So we've got the data, and what we're going to do today is a simple ingestion. So it means that I am going to put the data into Spark here, and it's going to be still Spark 245, I think, and I'll update that in the repo to go to Spark 300. Isn't that exciting? But anyway, so we're going to indent that. But the thing is, the data here, as you saw in the screen, is composed of a daily CSV file. Okay, so it's a daily CSV file. So it's going to be 18 files for June, 31 for May. We've got March, we've got April, we've got March, and we've got some of February. So yeah, roughly we'll count later, but something maybe like a 100 files or so. Okay, so that's 100 files. They are all CSV, so that's comma separated values, and we're going to ingest that into Spark. Okie dokie. So let's get started with our coding. Okay. So the first thing is we're going to do is so we've got the data which is physically in GitHub. Okay. So I've got my my 100 files. Oops. 100 files in a repo, and I'm going to the first operation is either to clone it, okay, or to pull it, okay, if you already clone it. And so that's going to be on my local file system. I cannot directly ask Spark to ingest the data directly from GitHub, as you could probably imagine. And then we can start the purely the ingestion process. Okay. So let's go to code. Let's code, baby. Okay. Here is my Eclipse. Okay. So I have two labs. Okay. We're going to look. They are in this magical repository called Chapter 99, which is because it's never been published in the book, but it's still kind of related to the book. So it's this Chapter 99, and in that I have two packages. I've got a root package called net.jgp.book.spark.ch99.covid19, and then we are going to do a lab 100 with a simple ingestion. And let's run this one. Okay, let me first to make things a little bit clearer here. Just yeah, never do that. Okay. Yeah. So I'm first going to run my lab 100 here. Okay. So let's run it as a Java application. Okay. And look at my console. So see, log trace is first starting to sync the repository, which is basically the operation of getting the data from GitHub, and then it's creating a Spark session. It's ingesting the file. Okay, and I have my data here. Okay, some kind of random data. not random data. I've got yeah, I think it's actually randomized. I'll show you the sample function. So it's not always the last one, and it's actually loading all the data in this file here, and you see the schema here, which so fips is a string, and we can play a little bit with this. We're just going to look at that. Okay, so that's a simple data ingestion application. So let's have a look at it. So a little bit more imports. Ooh, someone did not clean his imports, so let's just clean the imports. Okay, that's much better. So we've got dataset, row, Spark session, my logger, and you see two utility classes here, which is a git util, and it's part of this project, and this data frame. So let's drill into that. First I initiate my logger, and then I create an instance of the app, and then I call start, and start says, okay, it starts by calling this static method called sync repository, which is going to look for the data, and look for the data in on GitHub. Okay, so that's my GitHub Git, the Git repository address, and this is where I want the data. So let's have a quick look at that. This is using a library called JGit, which is actually the core thing for the Git support in Eclipse. But you can just use the library separately if you want. And basically, what I'm doing is, if the destination already exists, then I'm assuming it's a pull operation. Versus if the destination doesn't exist, I'm going to do a clone. Okay, so creating a repository. Yeah, JGit is throwing a bit of exceptions there, but I'm going to start a new file repository on my local repo, and I'm going to then start a git command, and from the git command, I'm going to pull it. And finally, that's creating the pull command, and then I'm going to actually pull the data. Okay, so that's in case of the pull, the first time you're doing it, and the subsequent times it's kind of similar. I'm creating a git command. This time it's more concatenated. Okay, so I'm going to clone a repository, setting the URI. Setting the directory, and in one call as well, doing the call to this function. Okay, and if something goes wrong, it's printing whatever. It's logging the errors, and it's going out of the functions thing. So that's basically where we are. Okay, so it starts sync repository there. I've got my data. I've got my data. So what I can do from there is simply, well, you know the drill, like creating a Spark session. Okay, so ingestion of COVID-19 data. And I am going to ask Spark to bluntly ingest all the data, saying it's start.csv. Okay, so you can, when you're looking at the data with Spark, you can ask it to load several data files directly. Okay, so in this case, it's star.csv will read all the CSV files that I have here. It's going to be as you know, then when I'm reading it, it's going to be one data frame. It's going to read, the format is going to be CSV. Options being, I'm going to ask them to infer the schema, so infer schema true. The option is yes, every single file has a header, but we'll have to look at the data to guarantee that, but we can do that, and then we're going to load all the files. Okay. And then basically what I'm going to do is just display the data. So let's look a little bit at the data as it is now. Okay, so it has a FIPS, which looks like a number to me. Okay, If you're not familiar with the FIPS, it's I'm spacing out on the acronym, but you can find that in definitely on Wikipedia. But it's the number of the state and the number of the county. Okay, so and each so that's typically US. Okay, that's sorry if it was not clear, but you see here Virginia being 51. You see that Albemarle is the number 3 county. If I'm looking at North Carolina, the Alexander County is 37, and you see this kind of data. Okay, so that's defining. It's only for the US, and my data set is not only for the US. Okay, I have, yeah, I said I've got it's a county, but it's not really the it's also they call that admin2, and you can look at that in more detail. It's more like a who is actually sending the data, and the province or state and the country or region, and then the last update, latitude, longitude, the number of confirmed cases, death, recovered, active, and the combined key, which is basically trying to make a key. There is then the incident rate and the case fatality ratio, which is statistical information. If I look at the inferior schema here, you will see that basically everything is a string. Okay, except for the incidence ratio. But my FIPS, as you saw, my FIPS is it's a numeric value. That's a string for sure, that's a string. The last update is definitely not a string, it's a date. Okay. And latitude, longitude is not string, and then of course confirmed death, recovered, active, all those should be integers. So it clearly means that the schema, the inferior schema, did not work as we were hoping or expecting to be. If I look a little bit more at this data frame util show method, it's using it's sampling the data before it, so I can actually sample the data a little bit more, and we'll see what the results are after this sampling. I like to show you a few data sets before we drill. So this is a very simple ingestion. Okay, so as you see right now, one of the problem we have is that we are not having we are not having the right data types, for example. Okay, so this the schema did not change, but the last update is it's still US. Okay, so that's actually where things are really important for us to look, is really trying to understand if the data is actually matching our expectation. Okay, and as you know, this is live, and so it's not always working the way you want. Okay, let's just not sample the data. Okay, we're just going to not sample the data, and I am going to show the first 100 rows of this record, and while it's running, I'm going to have a sip of tea. Okay. So if I look at that, it seems like I still have similar values. So you see, it's starting when I say it's the last values there. It's also because there's no guarantee in the Java application or Spark will read the file from the file system, and we'll just have a look at the file system right away. See, the schema is the same thing. No way to tell him that it's a date. Well, I could actually specify it as an option as well. And okay, so not seeing what I want. Let's continue digging a little bit into this data. Okay, so I'm going to modify slightly the ingestion to show only the very beginning of this dataset. So it was 2020-01. So we're going to focus only on the January data here. Okay, so the ingestion will be a little bit faster as well. Ooh, did I miss something? You will also see after you refresh that your data is going to be in Eclipse. So you can see here that I've got my COVID data and my daily reports. So I see here, yeah, it's I'm just going, sorry, I did that. It's US dates. Okay, so 01. Okay, so I'm just going to look at the data for January. And you've got to refresh here, like, you know, I've got to do data refresh because this data is not originally part of the repository you're going to clone, just added after. Okay, so that's a little bit interesting there. And you see that here for there's less column in January. Okay, so the format was slightly different, and so that's mainland China. And you see the last update. It's still not recognized as a date, still a string. Okay, and you see that it's not at all. It was before, it was the ISO format, and that's kind of the American date and the 24-hour date hour format. And you see that, yeah, you see some of the US data coming in. Okay, so in late January. So let's just quickly look at, do the same thing for February. Okay, I'm just going to do the February data set as well. Okay, so here when we look at it, it's very similar. So I've got the same thing: province, state, country, region, last update, and now you see that it's the ISO format for dates. It's the number of confirmed cases, death, and recovered, and you see that for a mix of February dates. Okay. Okay, and yeah, you see some little things here. If I'm looking at March now, let's run March. So if you remember, March is really where a lot of people realize that it was at their footstep, especially in the US. So you see a lot more data from the US. You see that the data set has been, so you see the FIPS appearing there, and you see that it's getting wider with more columns. Okay, so in this situation, if I run it again, let's run it with everything. In this situation where I don't feel very comfortable about the not the quality of the data. I trust the quality of the data, but the quality of the metadata and the quality, like the date format, like the number of columns, the data types. So for all these things, I don't feel really confident that my data is going to be ingested in a very secure way there. So that might be a little bit trusting too much about what is going to happen within Spark. So so I just run it with all the data files, and you see that I have something like 299 and 603 records. So I'm going to just put that on my iPad, just taking note. Okay, so lab 100 ingestion was 299 603 records. Okay, so let's look a little bit at the data. Okay, so I can start a shell here. Okay. Yeah. Benefit of having plenty of monitors. I'm sorry, it's a little bit small there. So if I do just an ls-l, okay, you see all my files. I have an ll, of course, alias as well. And you see all the CSV. So if I do, what I'm interested in looking is what format, what the number of records per files to see. So I'm going to look at all my CSV to see that. Okay. So you see that I have got 299 and 70. So there's a little bit of a difference. So when I do a wc-l, I've got 299 file, the 728 records. Okay, I'm going to quote that records because that's actually the number. It's not a record, it's the number of lines I have on all my CSV files. But if you remember, we have the header line. Okay, so if I'm doing just a ll star CSV pipe, where am I pipe? wc-l, wc-l, I've got 149 files. So 149 files. Okay, is that correct? Just make sure that I didn't do anything stupid here. Oops, sorry. Yeah, that's right. I don't know why somehow red. We've got special attributes here. Okay. Okay, so it means that if I got 149 files, I have 149 headers, right? So the number of records should be equal to and I'm doing that live, okay, with you guys. I did not prepare to that level of details. 205,729, and I'm going to cheat, right? I'm going to use that. I'm not trying to pretend I can do that by add anymore. So this is 299 579 records. Okay, so there's already a discrepancies between this one and this one. So this is really, that's basic operations you can do on data quality, and data quality is really important in our world more and more, actually. So you don't want to lose data somewhere in the middle. So let's also look a little bit at the files, and that's a great thing with CSV, is that you can open them to see what's going on, and it's pretty human digestible. So if I open it, here is my atom with the file. So that's just a file we just opened. Okay, so you can see the header here, province, state, country. You see that you only have basically 46 records, if I don't count the header. And you see the date format. You see also that this is a CRLF UTF-8 file. Okay, so all those things are important. CRLF means that it's a Windows file ending. Even if I'm on a Mac, it means that the file has been prepared on a Windows machine. And UTF-8 is the encoding of the file. So let's look a little bit more into another file. Let's say towards the end of February. Okay, so looks like it's the same header. Okay, date have changed. Okay, date have changed. and you see that there's a T there. Yep, so far no major changes. Okay, let's look like okay, here they've added latitude and longitude, and the date format is still the ISO date format with a T separator. Okay, otherwise it seems kind of okay-ish. Okay, no big surprise there. Let's look at my oldest son's birthday. Ooh, things are changed there. Okay, so you see the FIPS, admin 2, province. So basically the header has been really changing there. Okay, and my date format is back to US date format here. Okay. Now I'm looking at April 1st. Okay, so April 1st they went back to a more ISO-like date format. Looks like the header is kind of, sorry, got too many. It was kind of the longer header. Okay. Here, yeah, I don't have the file. Sorry, close it by accident. Okay, but anyway, if I go like my other son's birthday, and you see that here longitude is now having an underscore. You know, it has an underscore too, but there's a little bit of a change. Is it a little bit? Not in the header. Okay, so same header. Okay, so you see that there's a variety of different headers, variety of formats, and that can actually mess up a little bit the ingestion process. So what I've done and that I would recommend is trying to have a different ingestion process per dataset, okay, per format of dataset, okay, you're importing. So I've got let me just update that again. Don't do that. Oh, come on. Okay. Okay, so I'm going to work on give you a look. I'm going to close that. Okay, and we're going to look at this application, which I call the realistic data ingestion application. So let's first run it. And I'm really curious about the results as well, because I have not run it since yesterday, and the data have been updated, so we might have a little bit of a surprise. So you see that it's a lot more verbose. You see it's varying ingestion 1, 2, 3, 4 that is being called here for the different data. Okay, yeah, it takes more time. Okay, ingestion's done. It's going to look for dump some stats now. That's going to be the same thing. Okay, come on, baby. Okay. So I'll explain. And now we have 261,154 records. Okay, and that's lab 110 ingestion. So what happened here? Let's look in details at what was going on and why it was also a little bit slower. So same thing, start, sync the repository, and then I went through ingesting all the files separately, and after creating the Spark session. So and you see that it's calling different ingester for the files there to see what's going on there. Okay, and then when I'm displaying my data, okay, it's actually taking various data. So you see here, well, that was a Diamond Princess cruise ship, and you see that there's all these fields, and they have been added. They have been added there, and it's actually making a little bit things data is going to be a little bit more complex here to analyze, but that's something. Okay. And you add the file, there's a record there by state. Oh, I think I've got a filter on this one. Let me just we've got to check the code. I've done something. Yeah, I've done something a bit ridiculous, I think, on this one. So we cannot really compare. Let me just check the code, and then let's just remove that code. Sorry, guys. Now I can rerun it. Okay, so it's going to be a little bit faster this time because I don't have the filter. And so that's only US. Okay. Come on, baby. Okay, so it went as a schema, and now it's counting. One way to make the count faster is to cache the data frame. Okay, and it's 299,603, so that's 299,603. So it's the same value I have here and here. Okay, so there's still something which is a little bit weird here that I've got to investigate and understand why. But at least we have the same value, so it means that we're probably having the right thing. So what did I do here? Okay, let's go through the code. I'm going to reduce that a little bit. Okay. Oh, Eclipse, please. Okay. So same thing. My imports. Okay. I'm using some of the functions here. And then I'm going to instantiate the class, and same thing, I'm going to synchronize my repo, create my session. Then what I'm doing here is I'm going to list all the files. So I'm going to create a list of files, and I'm just going to add to have files that are in this directory and that is ending by .csv. Okay. For security, I could have a to allow stream there. I don't know if they have mixed cases because this is not going. This is probably yeah, we could make it a bit safer. Okay, and that's ugly. Don't do that. Okay, anyway, then from that I'm going to iterate over each file, and the first thing I'm going to do is extract the header. So and this is going to be my key to select which ingester I'm going to use. I'm going also to check that the first character of the file is not going to be 0 with no break space, okay, which is a special character that is indicating, that can be indicating file format. So I don't want this as in my header. Okay, I will leave it up to Spark to handle this, but in my header itself, I don't want that. Okay, so I want to go to substring 1. And then I'm going to, and that's still in my loop, okay, and then I'm going to ingest that based on the header, okay. I'm going to call the ingest method on the file name, sorry, and the header I'm going to pass, okay. And if my intermediate data frame is not coming null, then and if my original data frame is null, then I'm just going to assign it, otherwise I'm going to union it. Okay, so basically it's going to create a data frame per file, and at this point I'm going to union it, which is an expensive operation. Okay, okay, so if I look now at my ingest method, what is going on here? It's a big switch. Okay, so it's a big switch where you've got I'm going to switch on the header value, and by case I'm going to give it to give a new ingester. Okay, so if you look at, you will be it might remind you that we just looked at. Okay, so the province, state, country, region recovered, and then I've got FIPS coming in, and if you look there, they also added the incidence rate there, and the number of case, and which was not there, and there was also this case where they just added the latitude and longitude. So basically what I've identified is that there is four different formats of the data coming in. Okay, so if I was just using one format, I would not it would not work as precisely as I want. And then it's calling the different ingest. So let's look at ingest 1. Okay, so ingest 1 is province, so there's no FIPS, and recover. So that's the simplest one for ingest 1. Let's look at ingest 1. So I'm going to first, instead of having ask Spark to infer a schema, I'm going to create a schema in this iteration here. So I'm creating the schema. Okay, and then after that, you see that I've got my types as I want them. Okay, so for example, the last update is going to be its timestamp type. Okay, so so that's things that we will see I'm benefited from, and then I'm reading that. Okay, and you see that I've got more. I've got more, like in my schema, I've got more than what I'm actually going to read. Okay, so this this file here is going to be for the short format. So we have a short format here, like at the very beginning what we had. Okay, so let's just look at the data quickly. Get back to the data. I should have closed that. Okay, so like say January 23rd. If you look at the data here, you see that it's province, state, country recovered. Okay, so this is the schema. So in my schema, I already added the extra columns like active, which is a number of active case, combined key, incident rate. Okay, which will appear in future data set, but I'm kind of already putting the data types here. Okay, so that's what's it's interesting to be able to do at this stage. Some columns I could not set in the schemas here, so I'm just creating them from scratch. Okay, which is a FIPS, admin, latitude and longitude. I could actually put them in the schema at the end as well. Okay, if because I'm using a union by name, Spark is going to union based on the column names. Okay, so I could that, and I could actually force a schema. If I look now at my, so that was ingest 1, I can look at, let's say, ingest 2, same scenario, creating the format. Okay, and here I'm creating a format with every columns. Okay, so I could use the same schema. I just need to be very careful about the order of the columns, because the order of the columns have also changed in the various formats we've been getting from Johns Hopkins. Okay, and same thing here, read, format CSV, schema, option header, and load. Okay, and same thing if you look at number 3, doing the schema, specifying the schema there again, and same thing for 4. You know, it's getting similar. What changes, and I leave that to you, is the the schema is a little bit different every time. Okay, so to make sure that it matches really what's in the order of the columns that is going to be that are going to be parsed. So that's a difference. Okay. So, and when I get back to my ingestion, as you see, that's what I said. I've got my union by name, and then this is old code. Sorry for that, guys. Okay, bye bye old code. Bye bye old debug comments, and I'm leaving this one for now. But then I'm going to show the stats here. Okay. Just saving, and if I run it again, sorry, super small window here, so it's reading all the files. Okay, and now you see, maybe you understand a bit better the different ingestion which is calling here. And if you look at the full comment, you know, it's actually showing the header. There's a line header because I struggle a little bit with this non-breaking zero length white space. Okay, and now we're entering the part where it's doing the statistics. Let's give it a little bit of a time to finish that. Time for tea. Okay. Yeah, so similar kind of results. But what you can see already from that is that all the dates are completely unified. Okay, and now one of the key things is really looking at the records. Okay, so states string works, country string works, last update is a timestamp, confirmed case is integer, death integer, recovers integer, active integers, combined key, which is really some kind of a key here. Is going to be it's going to be a string. The incidence rate is a double. I think that was already the case when we let Spark completely infuse the schema. And then the FIPS is an integer. I forced it into an integer. And the admin is a string, and the latitude and the longitude are doubles. Okay, so yeah, even if there we have null values, you can see that we clearly have a dataset which is of a higher quality because of first dates, and then the data types are also correct if we want to do sums and things like that. So there's definitely other ways to take the easy ingestion and then cast or transform the data, but I feel more comfortable with this operation where I'm looking at the data and analyzing the format of the data before I'm actually putting them inside. Okay. So yeah, you've got, for example, you've got Orange County. It's still an early data set. That's why I'm using the sample method. Because it's kind of a little bit creating a more a little bit of a sample of the data, which, you know, almost like a bit of a random thing. So let's redo that sample. Let's do a sample of, I don't think 1 is a valid value, but I could do 9. So that's the scope on which it's going to sample the data and then just show the data here. Okay, so we'll take a little bit more time. So yeah, so while it's ingesting, so yeah, it's lengthy. The union by name is an expensive operation, but on the other end, it's I find it more comfortable, more reassuring that I know exactly the data I'm ingesting. So I'd rather spend a little bit more time understanding the ingestion process than just completely leaving it up to Spark in this scenario, so that I've got the date here. If I needed to convert every date field after, it would be a really it would be really problematic for me to go over each field and say, hey, that's a format, because Spark is expecting the kind of y slash or dash dash day pattern to be able to convert. Yeah, so I've got a bit of a more of a mix here of data. Not really. Yeah, the sample didn't work as I was expecting it to work here. Well, no big deal anyway. So, but you've got the gist of it. It's a different data set. I wish we could actually filter on that, but you can also do that on your own. So anyway, so that's the key thing is you definitely have to look at your data. Really look at the data. Try to understand what the data is. Don't underestimate you as a human, your capability to visualize the data and understand what the data structure is. If you skip this step, you may just have more errors and than we had here. And then you can start your analytics with a more solid ground. Okay, you're kind of really going to be able to understand better what's going on, especially if you're going to do analytics. The fact that we're going to have dates is going to be really interesting. And don't forget that if you're planning to do machine learning on that, the more quality the data is coming in to train your model, it's going to be a more successful result at the end of it. Okay, so that's it for today. I'm sorry this episode was a little longer. I took a day off, so more time to spend together. And I am going to continue and studying a little bit this data set. So expect more labs around this data set, which is going to grow. Okay, unfortunately, as the virus is spreading. So let's look a little bit at that. Let's understand a bit more the data, and let's meet next Friday for another episode of Data Friday. Thank you.